Okay, so I think I've got this figured out. I made sure that that first part was on YouTube. And look, you even get this little fun part of me if you want to see me or not. Okay, so here we go. We're going to keep going with these notes. So I want us to reduce the following. This is going to be important, and you're going to see I'm going to start easier and kind of build up to some things that we really need to know in this unit. So here I have the same base going on, so I could decide how I want to put these together. If I want to bring everything to the top, I would subtract this exponent minus this exponent, but I can see the exponent on the bottom is bigger, so I'm going to put them all to the bottom. So this would be that n plus 2, and then I'm going to subtract out now, bringing that down, the n minus 1. So this would be 1 over 10, the n's cancel, 2 minus a negative 1 would be to the third. So that would be the most reduced form of this. Okay, let's look at the second one. So here, again, I'm bigger on bottom. So I'm going to have the n plus the 1. And then I take this n minus 2 minus the n, and I'm just left with 2. So hopefully those weren't too bad. Another way that you could see them, if that was confusing, let me just show you one more way, is you could split up the exponents. You could say this is 10 to the n times 10 to the negative 1 over 10 to the n times 10 to the 2, because that's kind of essentially when you add, it's because you multiplied the same basis. And then you can see that those cancel, and that's 1 over 10 to the third. Same thing here. I could do the n plus 1 to the n, and then the n plus 1 to the n times the n plus 1 to the 2, n plus 1. Those guys cancel, and you're just left with that n plus 1 squared. So whichever way you like to do it, that's kind of up to you. Yeah. So here on number 3, now I want us just to simplify this inside. So we're going to keep the limit out in front, and we're going to simplify what's going on here. So this, if you liked that other way, is 2 to the n times 2 to the first. So I can cancel these 2 to the n's. And if we remember, the n plus 1 I can take out and then leave that as n factorial. So now my n factorials cancel out. So I'm left with this 2 over n plus 1. And now I can actually take the limit of that. And so as I go to infinity, I think bigger on top, bigger on bottom, or the same. Here I can clearly see this. There's only n's in the bottom. It's bigger here. It's growing bigger. So this would be 0. Okay, we're also going to need to be simplifying. I know these seem like really easy or something, but they're the hiccups where a lot of kids mess up on signs and things. So I want us to simplify number 4. So we're going to do that same thing with the base, where we're going to take that negative 1 to the 2n times negative 1 to the first. And then here, hopefully by the end of this lesson, you guys are just going to say that's a 1, okay? Negative 1 to any multiple of a 2, so any even, you are going to say, well, squared to the 4th to the 6th, that's going to just become 1. When I have an odd, that's going to stay negative 1, and then you have the n. So basically, this is the same as negative 1 squared to the n, which is just 1 to the n. And 1 to any number, absolutely any number, is always 1. So I really want us to get used to when we see this, if you want to highlight it, okay? But negative 1 to the 2n is going to be 1. And you can think through it every time if you want, or you can just kind of get it down. And then we still have that times the negative 1, so this would end up being 1 times the negative 1 here, which is now negative 1. So this no longer, we don't even need an n anymore. This is just negative 1. Okay, so let's look at 5. I need to erase some of this. So 5 says we're going to take the negative 2 to the 2n, and then the negative 2 to the 2. So I'm going to put these together and make that negative 2 squared is going to be now 4 to the n, and then negative 2 squared again is 4. So this is actually, we could say 4 to the n plus 1, or we could just leave it 4 times 4 to the n, depending on what we're trying to get our end game to here. Okay, let's look at number 6. That's negative 1 to the n times negative 1 to the 12th. Negative 1 to the 12th is just 1, so we're left with just negative 1 to the n. And that's how we have to leave it. Try 7. So negative 1 to the 11th is negative 1. Negative 1 cubed is negative 1 to the n. So now I can put that together. That's negative 1 to the n plus 1. Or you could leave it as that negative 1 times negative 1 to the n. Either way is fine. Again, for what we're trying to do, one may be more beneficial than the other. So we want to make sure that we understand both. Okay, so here we're going to talk about changing the summation of our starting value and how that affects the rest of it. So let's say that I started, that was cool. Let's say that I started with this one right here, but instead of starting at 2, a lot of times we have to start at 0. So if we have to start at 0, then I need to go manipulate. So I said, well, if I take this 2, I would have to subtract 2 to get to 0. And we can't just subtract without balancing it. So if I subtracted 2 from n here, then everywhere I see an n, now I have to add 2. And then I can reduce whatever that becomes. And here, make sure you can see step by step what happened. So let's try this one. I'm starting at 1, but I want us to start at 0. So this would mean I'd have to subtract 1 to get to here. So everywhere I see an n, I'm going to have to add 1 to balance out the subtraction. And we have to use parentheses here to make sure that we add it to that whole n part. Where was I? This one, you can use parentheses, but see, I'm not having to really distribute the 2. So if it makes you feel more comfortable to always start with all of them, then that's great. I'm really trying to work on making this prettier. It's really hard. Okay, 2 and plus 2 plus 5 would be plus 7 over 3 and plus 1. And again, depending on what we're trying to do, that may be great, or we may want to reduce this to 3 times 3 to the n. Same thing, okay? So we'll just have to see later, which you're so excited about. Okay, why don't you see if you can try this one on your own. Pause me and then unpause me. So I'm just going to rewrite this as the 5 squared is 25 times the 5 to the n over that n plus 2 factorial. You may have just left it, but this is an equivalent thing. So let's just think about this for a second, actually, before we move on. Let's put in some terms and see how they actually are the same before we go. So let's go get maybe purple. So let's start this one here at 2. So this would be 5 squared, 25, over 2 factorial, okay? And then the next term would start at 3. So 5 to the third, 125, over 3 factorial. And then the next term would be 4. I'm just going to write it 5 to the 4th, over 4 factorial. And we would keep going. We'd see that that general term is 5 to the n over n factorial. But this was my first term, and I keep adding. Well, let's come over here and see what that would be if I started at 0. So 5 to the 0 is 1 times 25 over 0 plus 2 is 2 factorial. Same exact starting thing. Plus, now here I start at 1. So this would be 25 times 5 over 1 plus 2 factorial, which is 3 factorial. Same exact thing here. So I could see as I keep going, these terms match up term by term. They started exactly the same spot, and you add exactly like you would from before. So do you see how these are equivalent? These are equal to each other, mathematically sound. Okay, it's not like we're starting with a 1, then plus that. That wouldn't be equal because now we've got a different term involved. Okay? But those are equal. Okay, and try that last one and see if you can get it to the right thing to match this. That's a 9 over 32 times 3/4 to the n. I promise I'm going to get better at this as we go. Okay? If you don't get that, ask me in class. Okay, so this is what I was talking about before, like a geometric versus the arithmetic. So geometric is when you are multiplying, and remember, you can multiply by a fraction, which is division, and arithmetic is adding, and if I add a negative, that is minus, but it's technically, we can always think of adding. So this is when we look at this, a lot of times we want to find our A and R. For geometric. So we want to get it in this term, a times r to the n. That's the goal, is to see that. And then over here, for arithmetic, it's kind of a linear thing. So we want to get it with this a plus bn, kind of a linear, constant, and slope. Okay, so let's go look at this first one. If I wanted to look here, I can see I went up by 4, I went up by 4, I went up by 4. So I'm clearly adding 4 to each term. This is arithmetic. So if I'm adding 4 to each term, that is my slope. 4 is my slope. So if I start at 0 and go to infinity, I know that I'm going to have a slope of 4. So I'm going to put the 4 with the n. And then if I start at 0, then that's 0, but that doesn't match for my first term being 3. So I'm going to have to say plus 3 in order for those to match. Now let's just double check that we did it right. Plug in a 0. 4 times 0, 0 plus 3 is 3. Let's do our next one. Plug in a 1. Well, we get out 7. Plug in a 2. We get out 11. So this is the summation form here, with the sigma and everything. We've turned it into a series form for this right here. That was my phone. I said series, and it went off. Okay, so here we've got it into that. Exactly the same, but this is nice to see like what is going on overall. Okay, let's look at our first one. It's really hard to see what's going on between these two terms. So I'm going to go ahead and go to this term and then look at this term. And you see on the bottom, it looks like you are multiplying by 2 every time. And then same thing here, I am multiplying by 3 every time. But then I've also got this plus minus, so one of these needs to be negative. So every time I am multiplying by a negative 3 over 2. And if I looked at this, what is this negative 1/3 times a negative 3 over 2? That would be 1/2, which is the next term. So sometimes the first ones can look a little bit different, but they really are part of the pattern. So this one is going to be this a times r to the n. Our r that we are multiplying by is that negative 3/2. So that's what goes on the inside. That's what we are multiplying by each time as we increase. And then whatever that first term is what's going to go here when I start at 0. And you can keep plugging in again, and you're going to see that this is what you get exactly. Next thing is graphing. Some absolute values can be easy and hard. I'm going to show you some ways of doing this. So you can do it a couple ways. You can solve using algebraic techniques. So solve algebraically. I think I spelled that right. Okay. Or you could go graph it. And actually, like when we graph, remember, like if we're greater than, we shade below. If we're less than, we shade above, and kind of do all the fun graphing things. And I'm going to show you what both of those would look like here. And sometimes one way is easier than the other. It just depends. So on this one, I know like, oh, you guys are like, oh, I can put that with what I learned in Algebra 1 and get rid of the absolute values, flip the sign here and negate, right? And set it up like this, and then we could keep solving. So add 3. Oh, lights went off in here. Okay, and then add 3 over here, and then divide 3 by 2. So that's one way we could definitely see that. We could also graph this and say, I'm going to graph this in like 2 and minus 3, kind of like this 2x minus 3, the absolute value. So I know that the vertex here would be at 3/2. We could plug in some values. At 0, I know I'm at 3. Plug in maybe 1. At 1, I am at 1. Okay. And we could keep graphing. And then we're looking for where is that going to be less than 1. So I'm going to like say this is 1. Where are we less than that is on this interval. And this interval happens between 1 and 2. Those are where I have less than 1. So this would occur when we are in between this 1 and 2. Okay, so you can solve this way, and either way, whichever you like, and see if you get to this answer. So I want to show you some, those are like Algebra 1 ones, so I want to look at some that are a little bit more advanced. So we could think of this guy graphically, this absolute value of x cubed. So we could graph this x cubed absolute value. So remember an x cubed looks like this, and then if I did the absolute value of it, it's going to bring the negative part and flip it above. So it looks like a parabola when you do the absolute value, but it's going to be more flat towards the vertex. So if I said, well, where is this less than 1? So again here, there's my 1, and I want to look on this interval, which occurred between -1 and 1. So that's one way that I could look graphically at this cubic and find it. So the algebraic method would be, well, pull out your cube, leave that part absolute value. And you may or may not have seen these. I don't know if they did that in pre-calc here or not. Okay. So then take the cube root of 1 to get this answer. Then use what you've learned before, what the absolute values back in Algebra 1, to make that the negative and the positive, and get rid of the absolute values. And so we'll get to the same answer. Okay, so let's try A together. So if I graphed it, I'm going to graph the absolute value kind of like x squared, and that's already all positive anyway, so I don't have to do any flips. And then I'm looking for where that is less than 4, so I would go to where this is 4 and see where that's less, and I know that that is between -2 and 2 are where those values would be. So I could say that -2 is less than n is less than 2. That would be the graphical approach. So if I was looking at this to go algebraically, then I would take this square and put it on the outside. And then I'm going to go ahead and take the square root, but we're only going to take that positive because we're going to deal with the negative when we bring the other sign. So we can go ahead and square root and get to 2. And then I've taken kind of care of that negative over here. So same thing. Okay, B. I'm going to go ahead and just do this one algebraically. If you guys like the graphical approach, then that's fine. I'm an algebra girl. So first thing I'm going to do is pull out the 1/8 and pull out the cube. So I can multiply through by the 8. And now I can cube root. So the cube root of 8 is 2. And then I can get rid of my absolute value bars. Okay. Oh, you guys, we're doing good. We have one more page. Okay, partial sums. Yay! We're finally getting into like some really good stuff here. Okay, so partial sums, just say only add up until, instead of going to infinity, so this could be, if I started at 0 and went to infinity, this is going to be an infinite sum. So a partial sum would be like, just go to maybe the 10th term. So you would only add up a1 or a sub 0 actually, okay, until a sub 10. And you'd add up all of those terms that you had. So if you started at 0, if we started at 1 and I went to the 10th, then that's where I would add up the first term to the 10th term. So that's just like a partial sum of an infinite summation that could happen. So here, if I just wanted one term, if I started at 1, then I would just plug in 1, and 1 over 1 squared is 1. Done. Let's say I wanted 2 terms added together. Well, I would take the 1 and then add on the second term, which is 2 now, so 1 over 2 squared is 1/4. If I wanted the third, then I'd add on the previous 2, and then take the third term here, 1 over 3 squared is 1/9. So this summation of whatever that would be is a partial sum of S sub 3, meaning take the first 3 terms. The nth partial term is where you keep going and you go to the nth. Now notice this will be exactly the same as what is going on inside the summation. And that's going to be really important to see that connection. The nth term is what is inside that summation. Okay? So let's look at this. It wants me to try to find some partial sums. This wants me to go to the second term. So on part A, if I want to find the second term, then I add the first and the second terms together, and I get 1/2. Let's go to the third. So that's just notation, S subscript 3 here, so S sub 3. And I'm going to take the first 3 and put them together, and that gives me 3/4. So remember that was like 0.5, that's like 0.75. Right now, it doesn't look like they're converging to anything, but part C says, does it look like it would be convergent? Well, I would definitely want to keep adding on more terms. That's hard to see if it's convergent or not. Remember how we said, well, when we're at the second term, we get, that's like 1, we got 0.5. When we were at the third term, we got 0.75. I don't know if that's going to continue to go up or if it's going to like actually converge to a number like, oh, that looks so bad. But like if it converges or if it diverges. Okay, so let's add some more on and see. I don't know. I'm going to go to like the 6 and see if I can see what's going on here. So I have the first 1 minus 1/2 plus 1/4 minus 1/8. Oh, that's only 4. I'm going to have to continue this pattern on. So I can see I'm alternating signs, that I have a 1 on top, and that I am multiplying by 2 each time. So there's the 5th, and then to get to the 6th, I can get this part. So this is actually if you put that in your calculator, go ahead if you want to, but that's 0.656 about. Okay, so in this case, let's look at this a little better, see if I can make it prettier. We went from, like, if I looked at to the top, if I looked at the first time, I was at 1, and then I was at a half, and then I was at 0.75, and now on down at the 6, I'm like at 0.656. So let's keep going. If I did s to the 10th, well, I could say, well, that's x to the 6 plus, we could just kind of add on and cheat a little bit. So now let's go to the 7th term past this. So that would be negative 1 over, that was what, 2 to the, so that would be 32 times 2, so 64. And then plus, the next one's, oh, hold on, this one was positive. This one's going to be a negative because we got to alternate. And then 1 over that 64 times 2. So that's the 7th, the 8th. And the next one's going to be a plus. 1 over that right here. What's that? 128 times 2. And then minus, let me get rid of me. And then minus that 1 over 128 times 2 more. And you guys can use your calculator. So let's do that. 6th, 7th, 8th, 9th, 10th. Okay, so let's take that 0.656, add on all of that, and see what you get out. And I got out approximately like 0.6666. So does it look like we are converging to a sum here? It does to me. This definitely looks like we are converging to 2/3. How cool is that? Even though we are adding on like forever and ever and ever and ever, we're going to get to a finite number. So super cool. That's the end of the free notes. I hope you guys liked it, and I will talk to you more.